Let's now discuss about electrons and shells. Each electron has different energy levels. Electrons orbit the nucleus of an atom at certain distances from the nucleus. Electrons near the nucleus have less energy than those in more distant orbits. Only discrete, that is, separate and distinct values of electron energies exist within the atomic structures. Therefore, electrons must orbit only at discrete instances and distances from the nucleus. Each discrete distance orbit from the nucleus corresponds to a certain energy level. In an atom, the orbits are grouped into energy levels which are known as shells. A given atom has a fixed number of shells. Each shell has a fixed number of electrons. Energy levels in the shells are designated 1, 2, 3 and so on, with 1 being the closest to the nucleus. Let's now look at the Bohrs model of the silicon atom. Notice that there are 14 electrons surrounding the nucleus with exactly 14 protons and usually 14 neutrons in the nucleus. We used silicon in this preceding example on purpose. The fact is that it has a half-filled valence shell with 4 electrons puts it in a spherical place. As is, it is neither a great conductor nor a superior insulator. With some attention to detail, it will become a semiconductor. Silicon is not the only material that can be used for semiconductors. In fact, many of the earliest semiconductors were made from germanium, and currently we make semiconductors from other materials too. Silicon, however, remains the source of most semiconductors today. Let's now look into valence electrons. Electrons that are in orbits farther from the nucleus have higher energy and are less tightly bound to the atom than those closer to the nucleus. This is because the force of attraction between the positively charged nucleus and the negatively charged electrons decreases within increasing distance from the nucleus. Electrons with the highest energy exist in the outermost T shell of an atom and are relatively loosely bound to the atom. This outermost shell is known as the valence shell, and the electrons in this shell are called valence electrons. These valence electrons contribute to chemical reactions and bonding within the structure of a material and determines its electrical properties. When a valence electron gains sufficient energy from an external source, it can break free from its atom. This is the basis for conduction in materials. Let's look into ionization. When an atom absorbs energy, the valence electrons can easily jump to higher shells. If a valence electron acquires a sufficient amount of energy called ionization energy, it can actually escape from the outer shell and the atom's influence. The departure of a valence electron leaves a previously neutral atom with an excess of positive charge, that is, more protons than electrons. The process of losing a valence electron is known as ionization, and the resulting positively charged atom is called as the positive ion. For example, the chemical symbol for hydrogen is H. When a neutral hydrogen atom loses its valence electron and becomes a positive ion, it is designated as H+. The escaped valence electron is called a free electron. The reverse process can occur in certain atoms when a free electron collides with the atom and is captured, releasing energy. The atom that has acquired the extra electron is called a negative ion. The ionization process is not restricted to single atoms. In many chemical reactions, a group of atoms are bounded together and can lose or acquire one or more electrons. For some non-metallic materials such as chlorine, which is a free electron, can be captured by the neutral atom, which forms a negative ion. In the case of chlorine, the ion is more stable than the neutral atom because it has a filled outer shell. The chlorine is designated as Cl-. The materials which are used in electronic devices. In terms of their electrical properties, materials can be classified into three groups: the conductors, semiconductors, and the insulators. When atoms combine to form a solid crystalline material, they arrange themselves in a symmetrical pattern. The atoms within a semiconductor crystal structure are held together by covalent bonds, which are created by the interaction of the valence electrons of the atoms. Silicon is a crystalline material. A little bit of details about insulators, conductors, and semiconductors. All materials are made up of atoms. These atoms contribute to the electrical properties of a material, including its ability to conduct electrical current. For purposes of discussing electrical properties, an atom can be represented by the valence shell and a core that consists of the inner shells and the nucleus. Let's look into insulators. An insulator is a material that does not conduct electrical current under normal conditions. Most good insulators are compounds rather than single element materials and have a very high resistivities. Valence electrons are tightly bound to the atoms. Therefore, there are very few electrons in the insulator. Examples of insulators are rubber, plastics, glass, mica, and